All right, finding the interval of convergence is the same thing as saying find the domain of a power series. Power series could be Maclaurin, Taylor. So I want to find the domain of the series. And what's the domain going to be? So before we had functions like 1 over x, we'd say, oh, the domain's where the x doesn't equal 0, right? Or if I had something like root x, we'd say the domain where this is bigger than or equal to 0. So what is good about a series? Well, things that are good for a series is when it converges. So that's what the domain of the power series are going to be. I'm going to be finding the x values where this series converges. All right, so that's called the interval of convergence. Okay, so when we're doing this, so one good news, we don't have to think about which test to use. We always use the same test. We always use ratio test. Okay, so limit as n goes to infinity, and we're going to be keeping the absolute value bars. So ratio test, remember the n plus first term, x to the n plus 1 over n plus 1 factorial, multiply by the reciprocal. Okay, so like I did before, right, we could just not even write in these negative 1 to the n terms because they're always going to go away with the absolute value bars. I have to keep the absolute value bars because I don't know about the x's. The x's could be negative, so I have to keep the absolute values. So I'm going to take the time to break this x to the n plus 1 up to x to the n, x to the 1, right? N factorial, and I'm thinking about how to break this up. You're expert at that now. And then this x to the n. Okay, so let's see what cancels. So the x to the n's go away. The n factorials go away. So let's see what I've got left over. So I've got absolute value of x over n plus 1. So let's talk about these absolute values. So the absolute value really just needs to stay on the x. So let me go slow through this. Limit as n goes to infinity. So I have absolute value of x over n plus 1. And so what I'm going to do is I'm actually going to pull this absolute value of x outside of the limit because this is a limit as n goes to infinity. It has nothing to do with this limit. So I'm going to go figure out what this is. So this limit here, 1 over infinity, that gives me 0. So I get absolute value of x times 0. That's 0. Okay. What test was I doing again? Oh yeah, I was doing the ratio test. So what does an answer of 0 from the ratio test mean? Since it's less than 1, that means it's absolutely convergent. So what that means is it doesn't matter what x value I use, I will get an answer of 0 from the ratio test. So that means it will be absolutely convergent. So let's think about that. So that what the domain of this series, right, negative 1 to the n, x to the n over n factorial, or what's called the interval of convergence, is all x values, so between negative infinity to infinity. I can't use infinity in here, right, because infinity is not a number, but if I use any number, this ratio test will give me a less than 1, it'll give me an answer of 0, which means it's absolutely convergent. So I just found out what the domain, what x's I can use into this power series. And power series, again, is just another way, general way of saying the Maclaurin or Taylor series. All right, let's go do this one. So again, we have to start off with limit as n goes to infinity. I'm not even going to write the negative ones in because I know the absolute values will take care of it. I am going to keep the absolute values because of the x. So remember, I'm putting in n plus 1 here. X to the n plus 1, n plus 1 all squared plus 1. Okay. So now let's take the time to simplify so that I can see what cancels. So this turns into 2n plus 2 factorial. This breaks up into x to the n times x to the 1. And then this is times n squared plus 1. This 2n factorial x to the n. And then I'm not going to multiply this out. I'm just going to be thinking about what highest powers would be, right? All right. So I want to take the time to break this down. Whoops, forgot my other absolute value bar. So I can cancel the x to the n's, correct? And then I have one x left over. So I'm going to take the time to pull that one absolute value of x outside. Remember, all the n's are going to be positive, so I don't need to write absolute value bars anymore, right? N's are always positive. So now I'm going to write out what this is broken down, which you've had practice doing this already. And that's all times, make that a little smaller up here, all times n squared plus 1 all over n squared, oops, I wrote that wrong, n plus 1 all squared plus 1, and then that's all times 2n factorial. All of these parentheses matter, right? Okay, so I see these two things canceling. So now I'm looking for highest powers, right? Highest power from the numerator. So I'd have a 2n and a 2n and an n squared. So that gives me 4n to the fourth, right? Okay. From the denominator, if I multiplied this out, the highest power here would be n squared. So if I cancel, I get 4n squared. What does that give me? That gives me an answer of infinity. Is that okay for the ratio test? It is. It's bigger than 1, so that means it's always divergent. Okay. So what is the interval of convergence? So a lot of times we like to short form things. We'll call it the interval of convergence. Since it always diverges, do I say nothing? Actually, there's one value. There's one value of x that if I use that right away in the very beginning, that it makes it all 0 so that it will converge. What x value would make this whole series 0? X equals 0. So the only value of x that works for this is x equals 0. That's the interval of convergence.